Hello, lovers of mathematics all over the notwithstanding the geographical location you are watching us from. Welcome to Increasers Mathematics Clinic. I'm your friend and instructor, Joseph, the director Increasers Model Academy. Today, we'll be exploring integration of function of a linear function. What is function of a linear function? Function of a linear function is a function in which a linear function is encapsulated into another function. For example, I have a function y equals to 3x plus 5 raised to the power of 3. This is a linear function because x plus 5 is encapsulated inside 3x plus 5 all raised to power 3. So 3x plus 5 is the linear function in 3x plus 5 all raised to the power of 3. Other examples are y equals cos 3x plus 5 equals 3x, which are 2x. So these are examples of function of function. So we are going to see how to resolve problems in integration that involves function of a linear function. Let's take an example. Y equals the integral of 3x plus 2 all raised to power 3 dx is a function of linear function. How do we resolve this? The first thing you do is to replace or substitute the linear function 3x plus 2 with any arbitrary constant. The arbitrary constants could be any letters of the alphabet ranging from A to Z. And for the sake of this particular question on the board, I am going to assign 3x plus 2 the value u. So let 3x plus 2 be equal to u, meaning that I now have y is equal to the integral of u raised to power 3 dx. So that is our new function now. Before we integrate 3 dx, we have to differentiate linear function which we assign a value u. So for us to differentiate this, we have that the u dx is equal to 3. How did this come? Let's take a look at the derivative of 3x plus 2. We know that if y is equal to 3x plus 2, then the y dx will be equal to x has the power of 1. So if you use the power of 1 to multiply this term, 1 times 3 times x raised to power 1, then you subtract which is 1 minus 1, 10 plus 2. Remember that the derivative of a constant is equal to 0. So each time you differentiate a constant, the result will be 0. So the derivative of 2 is equal to 0. So it means that our dy dx is equal to 3 plus 0, which is equal to 3. So our dy dx is equal to 3. And for me to substitute in the integral I will need to make the x the subject of the formula so that I can conveniently replace this value the x with the value I have here. So we have that the y dx is equal to 3x is equal to 3, meaning that the u is equal to 3 dx. So if I make dx the subject of the formula, it implies that my dx will be equal to 2 all over 3. So we are going to replace x with the u all over root 3. So what we do now is we will rewrite the integral of this, and that will give us y is equals to the integral of u raised to power 3 du all over 3. And remember that for you to a function that has a coefficient, you have to factor out the coefficient of that particular function. So for this, I'm going to be having 1 over 3, the integral of u raised to power 3. So I will now integrate u raised to power 3, and that will give me 1 over 3, open a bracket, u raised to power 3 plus 1, all over 3 plus 1. Then plus a c, because each time you integrate a function, you are going to add a c to it, which is the constant that was lost in the process of differentiation. So our result here will now be 1 over 3 times 1 over 4u raised to power 4, and that will be giving 1 over 12u raised to power 4 plus c is the integral of this particular function. But remember that we replace 3x plus 2 with an arbitrary constant u, and that is what we have here. So we are going to bring it back. 1 over 12, bracket open, 3x plus 2, bracket raised to power 4. That is what we have. And this happens to be our answer. And then we write it as 3x plus 2 raised to power 4 all over 12 plus c. That is the integral of 3x plus 2 raised to the power of 4. Thank you for watching.